Hello. Good afternoon, class. Now, welcome back. We're looking at moral concept today. Let us learn something new now. Now, I don't know if you covered moral concept. I don't know how you understand it, but let us look at it in details. Now, when I say moral concept, what do we deal with? We deal with the calculations out there, finding the masses, finding the moles, finding the volume, and the rest out there. Now we have the important things we should look at. So one, look at the moles out there. So you must understand the mole, you must understand the mass, you must understand the volume. So we shall look at finding the moles, the mass, the volume. Then we shall look at molarity and heat. Now heat deals with thermodynamics out there. That's also part of moral concept. Now, our main focus today is going to be on a mass out there. So our main focus is on the mass. So what should you know about the mass? Okay? Let us see here. When I say mass, how would you know it? Mass is weight, not so? So when I say weight, you know they're in what? Grams. Out there. So is mass as itself just what? Mass. Out there. There is mass, which is relative formula what? Mass. This is mass of a compound. Out there. There is mass in relative molecular what? Mass. This is of a molecule. This is of a compound. Out there. This is of what? A molecule. Out there. So we have relative formula mass in a compound, relative molecular mass in what? Then when we say relative, is always in one what? 1 mole. Out there. So when we say mass in general, it is many moles. Out there. It can be 1, can be 2, it can be the rest. But when you say relative formula mass, relative molecular mass, is always in one what? 1 mole. Out there. Let us look at an example. How do we find a mass of a given what? Substance. Out there. When I say a substance, we can mean very many things. Out there. So let us look at this. So looking at finding what? Finding the mass. Out there. So for what if I say mass of sodium oxide? Out there. I think we looked at finding the formula of sodium oxide. So 1, I have sodium out there, sodium what? Oxide out there. Now its formula is Na out there. There's a 2 here and what? O out there. Now we have sodium and what? Oxygen. When I look at a sodium atom, it has 2 what? 2 moles out there. Then when I look at oxygen, it has what? 1. Meaning the sodium atom has 2 moles, then the oxygen atom has what? 1. So how do I calculate the mass of a given what? Compound? So I'll go back to the periodic table where we have the notation over there. So how do I know the notation of a given element over there? Now back to the O-level concept over there. So if you have something like this, when I have the notation, this is the what? The notation of what? An atom. I have X over there. This is Z. This is what? A. Now the A is the what? The atomic number over there. Then this is the mass what? Mass number. If I look at sodium, sodium is Na over there. Here is 20 what? 23 and what? 11. Meaning this is the mass. This is the atom over there. That means the sodium is now 23 what? Grams. If I look at the oxygen, the notation of oxygen is 16 and what? 8. 8 is the atomic number, 16 is the what? The mass. Meaning this is got what? 16 what? Grams. So how would we calculate the mass? Over there? Now look at this. So we have this. So when I say sodium oxide, find the mass of sodium what? Oxide. Now we have 2 moles over there, meaning 2 times 20 what? 3 over there. Then plus, I have 1 mole of oxygen. 1 times 16, that's the what? The grams. Meaning I have 40 what? 46 plus 16 over there. So then I add. When I add 16 plus that is 12, that is 5, that is 60 what? 62. Meaning this is 62. But when I say relative formula what? Mass. Because it is a formula, it's going to be what? 62. Without what? The units. Why? because the units have no, when I say relative formula mass, we don't put the units because it is what? A ratio. Relative means it is a ratio. But you can also say formula what? Formula mass, formula what? Mass is equal to what? 62 grams. Know that? So specifically, that's what we look at when they say find the mass of a given compound. Find the mass of a given element. Over there. Now let us look at another example. Now what if they tell you mass of magnesium oxide? Over there. So now example 2. Example what? 2. So we're looking at mass of magnesium oxide. Now magnesium oxide is Mg and what? Oh, that's the formula of magnesium oxide. I have one element of what? Magnesium, one element of what? Oxygen. Meaning magnesium has what? One element. Oxygen has what? One. Over there. So that means the number of moles here, 1 mole, 1 what? 1 mole. What of the notation? Over there. So if I look at the notation of magnesium, magnesium is Mg. Here is 20 what? 24 and what? 12. Meaning the mass is 24. If I look at oxygen, which we already know, this is 16 and what? 8. Meaning the mass of magnesium is 24. The mass of oxygen is what? 16. Therefore, what do you have? Therefore, if I have magnesium over there, oxygen over there, so it means 1 mole times what? 24 brackets plus, this is going to be what? 1 times what? 16, which is already 16 over there. Meaning I have 24 plus what? 16. Well, 6, that's going to be 10, then that is 40 what? Grams over there. Because this is 3, that is 40 over there. That meaning if it is relative formula mass is equal to what? 40. If it is formula mass, that means formula what? Mass is equal to 40 what? Grams. Now I like this very much. Try for me the formula, find for me the mass of sodium hydroxide. Mass of sodium what? Hydroxide. Now that's going to be the end of our chapter. Now this is Walter Moses, your teacher. Walter Moses. Like my videos and share them. Thank you for listening.